Welcome, my friends. I'm so excited because in this video we get to introduce confidence intervals. So let's go ahead and get started. Let's say I want to estimate the population mean amount of student debt for all recent Grand Valley State University graduates. Assume that I sample 100 recent graduates and find the sample mean, X bar, student debt to be $20,000. Since the mean that I've calculated is only based on a sample, it probably does not perfectly represent the population mean student debt of all recent Grand Valley graduates. We would need a census of all recent Grand Valley graduates to find this value exactly. Now, even though our sample mean is not the same thing as the population mean, it's most likely pretty close. So we might say that our sample mean is an estimate for the population mean. The term that we use in the context of this chapter is point estimate. We would say that our sample mean of 20,000 is a point estimate for the population mean. In other words, $20,000 is our best estimate for the value of the population mean. But since our sample mean of $20,000 is probably not a perfect estimate or a perfect point estimate for the population mean, we're going to create a confidence interval centered around $20,000 that we can be some percentage confident that the true population mean falls between. The easiest way to visualize this is on a number line. We would have our sample mean of $20,000 right down the middle. Then we would have some number that's a little bit less than 20,000, let's say 19,500 as our lower bound, and another number that's a little bit larger than 20,000, let's say 20,500 as our upper bound. We call the distance from our point estimate of X bar to either the lower or the upper bound the error or the margin of error, which in this case is 500. The distance between 20,000 to 20,500 or from 20,000 down to 19,500 is 500 in either case. We might say that we are 95% confident that the true population mean falls somewhere between 19,500 and 20,500. This is the general form of any confidence interval. We're always trying to estimate a value based on the entire population, such as the population mean. Since we would need a census to find the population mean exactly, most likely we're going to settle for a sample mean, in this case X bar. The sample mean X bar is probably not a perfect estimate for the population mean, but nevertheless it is an estimate, and the term we use is a point estimate. Since that point estimate is probably not exactly perfect, we're going to add and subtract some error to get what we call the upper and lower bounds of our confidence interval. And then we're going to state that we are some percent confident, for example maybe 95% confident, that the true mean falls between our lower and upper bounds. A couple of important things to keep in mind are, one, that the error is only the length from the center of your confidence interval to either the upper or lower bounds. A common mistake is to think that the error is the entire length of the interval, which would be 1,000 in this example. The error is only the distance from the center or the point estimate to either the upper or the lower bound. Additionally, note that sometimes you might only be given the lower and upper bounds of your confidence interval, and you may be asked to find the point estimate or the value in the middle. If that was the case, you could take the average of the lower and the upper bounds to find the value in the middle, in this case X bar. Alright, here's a problem for you to try. If we had a 95% confidence interval for the population mean final exam score in a Stat 215 class at Grand Valley State University, and the lower bound was 72, and the upper bound was 84, answer the following. First of all, what is the value of the point estimate? And secondly, what is the margin of error? So once again, the point estimate is going to be the value in the center of the confidence interval. You are only given the upper and lower bounds. So those are taking the place of 19,500 and 20,500, in this case 72 and 84. So the point estimate will be the value right in the middle of those two numbers. And then the margin of error will be the distance from that number in the middle, the point estimate, to either the upper or the lower bounds. So go ahead and pause the video and give those a shot before moving on. The most common confidence levels are going to be either 90%, 95%, or 99%. The higher the confidence level that you use, the higher that margin of error is going to be. The lowest level of confidence that's still typically used is 90%. This is going to lead to a very low margin of error, which would look something like this. we would have our point estimate in the middle of x bar and a relatively small margin of error down to our lower bound or up to our upper bound. If you had a 95% confidence level, which is the most common confidence level, then you would have a little bit more error. We might say medium error. You'd still have the sample mean in the middle, but the distance from that sample mean either to the upper or lower bound is going to be a little bit larger than if you had a 90% level. And then finally, we have the 99% confidence interval, which is going to have the highest amount of error. We're going to have the highest distance from the sample mean either to the upper or lower bound of our confidence interval. The reason why the error increases as the confidence level increases is because if you want to have a higher percentage chance of containing the population mean, then you should use a larger confidence interval, including more numbers. The interval on the bottom, with the 99% confidence and the highest error, has the most possible numbers in the interval, and therefore is going to have a higher chance of capturing the true population mean. The one on the top with 90% confidence means that we only have a 9 out of 10 chance of capturing the true population mean in our interval, but we're able to have a smaller margin of error. If there's a smaller chance of having the true mean in the interval, it makes sense that the interval itself would be smaller and contain less numbers. Additionally, increasing the sample size would also decrease the error. So really there are two things you should be familiar with that will change the error. One thing is changing the confidence level. The higher the confidence level, the higher the margin of error. Additionally, the higher the sample size, actually the lower the error. So the confidence level and the error go in the same direction. The higher the level of confidence, the higher the error. And the sample size and the margin of error go in opposite directions. As the sample size increases, the error actually decreases. Now, once you've constructed a confidence interval, which we will do in an upcoming section, you might be asked to interpret the confidence interval, which is just another way of saying, explain what the confidence interval means in the context of your particular question. The general form you should use to interpret confidence intervals when you have one sample is that we are C% confident, where C is your confidence level, that the interval between your lower bound and your upper bound contains the either population mean or population proportion, depending on which type of problem you're doing. There will be a different confidence interval interpretation later when we cover two sample confidence intervals. Note that you should always describe the population mean or population proportion as it relates to your specific problem. So if your mean relates to the mean age of a Grand Valley student, you should be stating that when you describe the population mean. Also, you should probably use the word population mean or population proportion, or somehow indicate that you are referring to the population rather than just the sample. Confidence intervals relate to the entire population and not just the sample, so you should be clear of that in your interpretation. Here's an example for interpreting a 90% confidence interval for the mean student debt of a recent Grand Valley graduate. We would say that we are C% confident, which in this case is 90% confident, that the interval between our lower bound, which is $19,500, and $20,500 contains the population mean student debt for a recent Grand Valley graduate. In other words, we don't know what the true population mean student debt of all recent Grand Valley graduates is. We only have a sample, and we would need a census to know that value exactly. But we are able to say with 90% confidence that the mean falls somewhere between $19,500 and $20,500. This is the power of inferential statistics. We can take a sample and say something about the population. We only took a sample, but we're able to state with 90% confidence that the mean falls between these two values. All right, my friends, that finishes everything I wanted to talk about with our introduction to confidence intervals. In the next several videos, we will talk more about the specifics of how to construct the confidence intervals. So I'll see you in those videos.